Hello everyone. Today we'll be dealing with one of the important questions of tangent to a circle of CBSE class 10th. In this question, it is given that triangle ABC is circumscribing a circle of radius 4 cm and two segments of the triangle, that is AD and DC, are given as 8 and 6 cm. Now let us look at the figure and understand this. The radius of the circle are OD, OE and OF, which is going to be 4 cm. The segment AD and DC is given, marked in. So let's put up this information. So here the radiuses are going to be OD equals to OE equals to OF equals to 4 cm. Now we have a theorem which says that the length of the tangents from any exterior point are going to be equal. That means the two tangents which are drawn from the same exterior point are going to be of equal length. So here the two tangents from point A are AE and AD. So they are going to be of equal length. So AE is going to be same as AD, which is 8 cm. Same way, the tangent from point C are CD and CF, which are going to be of equal measurement. So CD equals to CF is equal to 6 cm. The two tangents from point B are BF and BE, whose length are not given. So let's suppose it as X. So BF equals to BE equals to X centimeter. Let's put up this information in the figure itself so that for the next step it will be easier for us to work with it. So here CF is going to be 6, BF is going to be X, BE is going to be X, and AE is going to be 8. Now to proceed with it, we are dividing the whole triangle into three different smaller triangles, that is AOD, BOC and AOC. So the step that we are going to follow is we are going to find area of AOB, BOC and AOC, which will add up to give me the area of ABC. So that is step 1. The next step is I'm going to find the area of ABC triangle using Heron's formula. So let's proceed with step 1, that is breaking the triangle into three smaller triangles. So that is these three triangles. So step 1, I'm going to talk about the area of BOC, AOC and AOB. So in this case, the height of a BOC triangle is OF and base is BC. In triangle AOB, the height is OE and base is AB. In AOC triangle, height is OD and base is AC. So we'll apply the formula half base into height. Let's take the area of triangle BOC as A1. So A1 is half base into height, which is going to be half times 4 times x plus 6, which will give me 2 times x plus 6. Next, A2 will be the area of triangle AOB, which is again half base into height, which is half times 4 times x plus 8, which will give me 2 times x plus 8. And the next one, which is A3, is going to be area of AOC, which is again half base into height, which is half times 4 times 14, which is going to be 28. So now we combine the area of all the three. That will give me area of triangle ABC. So area of triangle ABC is going to be A1 plus A2 plus A3. So if you add them up, we'll get this. So it's 2 times of x plus 6 plus 2 times of x plus 8 plus 28. So which will give us 2x plus 12 plus 2x plus 16 plus 28, which will give me 4x plus 56. So we'll keep that as number 1, which we'll come back to. So let's take it as A4. Okay. Now we'll go to area of triangle ABC using Heron's. So let's draw the triangle so that we are familiar with what we are talking about. So let me just put up the step 2, that is area of triangle ABC, whose three sides are 14, that is AC, x plus 6 is BC, and x plus 8 is AB. So the first step for herons is find the semi-perimeter. So it's x plus 8 plus x plus 6 plus 14 divided by 2. So that will give me 2x plus 28 divided by 2, which is x plus 14. Next thing is I'm going to do is s minus a. As per the Heron's formula, we need to do s minus a, s minus b, and s minus c. So let's find it separately and then we'll put it into the square root. So s minus a, s minus b, s minus c. So it's going to be x plus 14 minus x minus 8. I'm taking AC as a. So that will give me as 6. S minus b will be x plus 14 minus x minus 6. So I'm taking BC as b. So that will give me 8. Next is x plus 14 minus 14, which is going to give me x. So let me just mark a and b in the figure. So that is pretty clear which one I'm going to talk about. So this is going to be my b, that is BC is b, b is a, and AC is 4. See. Now we'll be putting in the Heron's formula. So the Heron's formula is area, let's say A5 equals to square root of s minus a, s minus b, and s minus c. So as per this, it will be square root of my s is x plus 14 times 8 times 6 times x, which will give me square root of 48 x plus 14. I know 48 is 16 times 3. So I can take the square root of 16 and I can change it like this. So I'm going to put that, I'm going to break off 48 as 16 times 14. Just hold on. So I'll be writing that. So that is equals to 16 times 3 times x plus 14 square root. So that will give me A5 as 4 times 3x into x plus 14. Now the area of which we found in A4 and A5, that is step 1 and step 2, they are going to be equal. So A4 equals to A5. Let's scroll up to find out what was A4. So my A4 was 4x plus 56. So we are going to say that 4x plus 56 equals to 4 square root of 3x into x plus 14. Now I can take 4 common in the left, so that will become x plus 14 equals to 4 square root 3x into x plus 14. So now the 4 and the 4 gets cancelled off. So now we'll take square root, so that has to be removed. That means we'll be squaring on both the sides. So when I square on both the sides, this is what will happen. It will give me x plus 14 the whole square equals to 3x into x plus 14. So now let's break off x plus 14 the whole square as x plus 14 times x plus 14, which will give me 3x times x plus 14. So clearly x plus 14 on both the sides will be getting cancelled off once. So I get x plus 14 equals to 3x, which will be 14 equals to 2x So my x is going to be 7. And then we'll find BC and AB. So here x is equals to 7. Thus the final step, that is, we have to find AB and BC. So AB was x plus 8, which is 7 plus 8, which is 15, and BC was x plus 6, which is 7 plus 6, which is 13. Thank you. Hope you enjoyed.